Fantastic.
Okay. Yeah, so I'll start.
Sure, yeah, go ahead. Yeah.
Okay, thank you. So very good morning. So slightly a little bit about myself. I am Moumita. I am a postdoctorate fellow at the Hong Kong University of Science and Technology, and I work with Professor Jack Cheng's group. So our group in the blockchain area, we do look at different applications of blockchain in the construction industry. But one of the things that we also look at is the security of data in construction industry. And based on our discussions with the industry, so we find out that security is always a concern because there is a large volume data that the industry is now handling, starting from BIM to construction documents and IoT information and so on. And also, it has also do with the contractual bindings between different parties, and people are skeptical to share their data fully. So security has always been an issue, and here ISO 19650 clearly states the requirement of security. So all these terms stated by, just give me a second. Yeah, sorry. So all these terms stated by ISO 6950 are kind of self-explanatory, like confidentiality of information, because a lot of sensitive information is present in say, industry data, integrity, and so on. But what I would like to emphasize on is the utility of data. So which is clearly stated that no matter what kind of technology we use to protect our data, but at the same time, we should be careful about preserving the utility of data or the functionality of data throughout its life cycle. So in this particular presentation, I will mainly be discussing about security in two areas. Starting one is submission management, and the other one is sharing BIM in a collaborative area, like in a more secure manner. So for the submission management, I would talk about that there are multiple data creators. So I'm basically talking about domain-based deliveries and the interlinkage of different submissions with each other. So in that case, like the security of submissions is a question. So I'm basically talking about the integrity of the submissions, and also during different workflows, the accountability of different submitters. For the collaborative data sharing with BIM, so even in BIM models, there sometimes might be different data owners. So this may be a case when we are talking about, say, subcontractor-based data ownership. So some subcontractors may be only be open to see the BIM models that falls within their scope of work only. So in that case, we are looking at a way to share B models in such a way that it doesn't lose its functionality, and at the same time it's secure as well. So the two parts. So let me go through the BIM submission management part first. So here, the problem with BIM submissions. Um, so first of all, in BIM submissions, there are multiple delivery teams, and hence there is a parallel working environment. And there are multiple versions of deliverables that are created in each domain, and there are dependencies also. So this is a simple example of a dependency where MEP model depends on structural model and the architectural model and so on. So an ideal case scenario would be that these submissions be created sequentially one after the other, but in a real life project, at least in Hong Kong, this is not the case. So these deliveries are generated over a skewed timeline, and as the versions and milestone progress, so there is always an overlap between the different submissions. So in this case, if the project is very large, so for example, right now we're working with ongoing project. It's a large project, and that has so far in the last 2 years more than 40 domains already. So as the number of domains go up, then we have complexities, and it's really difficult for a submission manager in this case to make sure that everyone, all the delivery teams are following the correct submission and something that is like completely, which is complete and the latest one. So, and if that is not the case, so who is accountable and how do we make sure that person is accountable? So to address this, what we do is we use smart contracts, and we also extend the existing IFC schema to capture these dependency rules and incorporate that in the workflow. And we also record the life cycle of versioning of Vim deliverable, like throughout its entire life cycle. The second issue that we address in BIM submission management is the problem of issue management. So same thing in case of large projects, it's difficult for the issue manager or the design manager to make sure that all the issues are being completely addressed. So there might not be any problem to make sure that the issues are being addressed, but sometimes some elements that are mentioned in the issues may not be completely addressed. So therefore, to address that, we incorporate an automatic checker to identify the unaddressed issues. And for accountability, we also record the life cycle of an issue from the beginning to the end for accountability. Now, this diagram shows the overall framework of the thing. And so this is rather detailed. So what I would like you to focus at is we have like two modules. One is the version management module and one is the issue management module. And the teams here are the different delivery teams. So, two are shown here. So it may like be more two, three, four, depending upon the number of domains in a project. And we also have a blockchain layer to record it. Now, to facilitate this workflow, so we have extended the IFC schema so that we can link IFC to blockchain and reverse. So here you can see that the first extension is for blockchaining submissions and to handle multi-domain version management. So we capture things like the model name, depending upon the model name that is required by a project, and also the dependencies, like if this is a particular submission, then what other submission does it depend on? And we also store a proof of the content of this model, so basically a hash. And we also have a provision for storing the blockchain transaction ID in the IFC file. And also at the same time, we also extend the IFC schema to make sure that the issues are marked in the IFC file so that like it's easier for checking the differences automatically. Uh, now, we are going to look at the version management module first. So here, this particular example, it shows that architect is trying to upload his file using this particular workflow. So, so this is the input that he needs to provide in his IFC file. So in our prototype, so we have a backend system, so which takes care of all these inputs. And after the input is made and the uploading is completed, so a record like this is created in the blockchain. And so as you can see that a proof of this file is stored, and the person who has submitted it, so his declaration is also recorded. Then after that, after the submission is completed in the blockchain, so then we update the IFC and store the transaction ID in the IFC so that like there's a two-way link between IFC to blockchain and blockchain to IFC for future references. Now, this part shows what does the dependency coordination module does to make sure that the dependencies are being followed. So here, the user is a dependent user, a structural delivery beam deliverable submitter, and so his deliverable depends on the architectural deliverable. So in this case, when he attempts to submit his BIM model, so based on that, a smart contract is triggered, and the smart contract checks for dependencies. So if the dependency check that is performed by the smart contract is that, so if the corresponding leading architectural file is not downloaded, so the structural delivery team's deliverable is not allowed to be uploaded. So this is just to ensure that at a later stage, delivery teams are not able to tell that they didn't have the access to the correct leading files. So, and all this information is also recorded on the blockchain. Now, this is just our prototype. This is the front end of our prototype that is connected to the blockchain. So that allows you to create different rules So for example, dependency rules connecting different domains, and we allow that to be created on the fly, and we allow that to be connected to a submission so that it's governed by that. And you can also view the B model on this platform. Now, coming to the issue management module. So as I mentioned earlier, so we also integrate an automatic checker to make sure that all the aspects of an issue are completely addressed. So here, uh, when say a issue author generates a new issue, so all the information is recorded on the blockchain. So here you can see that this issue record is put in the blockchain. And at the same time, it also requires an IFC file, which has the different actions marked on the IFC file. So for example, issue requires that you move a particular door by 2 centimeters. So the action would state that it would be marked on that particular element, and it would mark it as modify. So after that, this particular module checks for the unaddressed issues. So I'll be describing that in the coming slides. And if all the issues are addressed, then the issue author is notified, and he has the right to go ahead and close the issue. And it also generates a report like that, an Excel file. So basically, it tracks what were the building elements that were part of an issue, and whether the necessary actions were taken, like if the geometry was changed or location was changed, and all these are documented in this report. And this report is also blockchain. Then this slide shows you the automatic module checking for the unaddressed issues. So here, so what we do is, so for checking the differences between two IFC files, so this is actually a part of a large project, and we were handling Beam files, so which went up to 1 GB. So for large beam models, so methods, so simply comparing the two IFC files did not work. So it was taking a long time. So rather, we went ahead with this segmentation approach. So where what we were doing is, like, we were segmenting the beam model based on space, zone, or floor. And initially, the first step was to convert these different parts into hashes, and we did the comparison of hashes first. And if we found any changes or any differences between the hashes between the two models, then we went ahead and we checked whether there was any geometrical change or any property related change or location related change. And yeah, that's how it was done. And this approach did give us significant improvements. So 6 to 7 hours to we reduced the time to like 14 minutes because of the segmentation based approach. Now, the second part of my presentation deals with component-based beam encryption. So this is mainly to allow a sharing of beam model where there are different data owners in a more secure manner. So the idea in a simple way is that we encrypt different parts of a BIM model with different encryption key. So for example, this picture shows you clearly that this part of the BIM model is encrypted by this particular user, and the other part is encrypted by another user. Now, this approach will not work using proprietary BIM formats like Revit. So therefore, we went ahead and we chose IFC to do that because of IFC's entity-based data format, so which is much easier to do. But so although having a partial encryption like that has benefits of its own, but it also comes with certain problems. So for example, data integrity concerns of the whole model. So to put simply, so if you have a BIM model where you have encrypted different parts with different encryption keys, so the integrity of the whole model may be questioned because there are relations between individual parts. And while encrypting, so if you're missing out on some relations, so it might hamper the integrity of the entire model. The second one is the integrity of the encrypted parts, rather. So if I'm the owner of an encrypted part and if I do some changes in it and there's no way to figure out by the manager to whether I have made any changes or not, so it hampers with that as well. And so obviously increased management complexity and collaboration challenges. So address that. So we have extended IFC schema, and we also use Hyperledger Fabric to address some of the issues here. This is the extension. So I'll quickly go through it. So in the extension, what we do is we have a provision for storing the encrypted data inside the IFC file. And we also keep data proof of the encrypted section, and we blockchain that so that like no one can, any data owner cannot go ahead and make changes to his part also, like without the correct permission and approval. And the methodology is mainly what we do is we try to maintain the functionality of the meme model. So we make it useful for, say, a clash detection or an energy simulation. So what we do is while encrypting different elements, so we try to maintain the overall shape of that element while removing the different details of the same. So yeah, so I'm running out of time, so I'll just quickly go through this. So this is just some of the results, and we find out that these are like working pretty well. So some initial results. So we are working further on this, and so this is just what our team does, and we are working further on all these parts. So yeah, so thank you for your time, and this is my team at HTUSD, and thanks for listening.